Good morning and welcome on behalf of GreyCampus. I am Phyllisia Taylor, project management professional and Lean Six Sigma Green Belt professional. I will be your host this morning, and this morning we will be covering the topic of quality. We will cover the 7 basic quality tools that you need as a professional to be empowered to make confident decisions in your professional roles. So let's begin. So again, we'll be covering the 7 basic quality tools, and this is in pursuit of excellence because we do know that in quality or in project management, let's say in project management, there is the knowledge area, project quality management. And in that knowledge area, we do plan for quality, we manage quality, and we also control quality. And these 7 basic quality tools will definitely help with planning, managing, and controlling quality in your work environments and even in your personal life, if you so choose. Before we get into the 7 basic quality tools, I'd like to discuss our definition of lean and how lean works. So you heard me say that I am a Lean Six Sigma Green Belt professional. So how lean works, lean focuses on reducing waste to increase flow in all processes. So lean can improve the performance of all design, fulfillment, and support processes. As a matter of fact, a lean project seeks to identify non-value add tasks and eliminate them. So we want to eliminate or reduce waste. And waste appears in multiple forms. It could look like poor materials, clumsy policies, poor communication, no teamwork, hierarchical organizations, fear in the workplace, or rigid workplace environments. All of these things create waste. And then Six Sigma, let's talk a little about Six Sigma. Six Sigma focuses on reducing the variation that generates defects or errors that impact our customers. And variation makes it hard to manage and anticipate results. So a Six Sigma project seeks to eliminate the root causes of variation and raise the Six Sigma value of the production process. So eliminating that root cause of variation, we first have to identify that root cause. And that's what these 7 basic quality tools will help you do, to identify root causes. And then they will also help you to, or empower you to make some very strategic decisions in how you'd like to go about reducing waste, eliminating waste, and reducing variation. So let's look at these 7 basic quality tools. The first on the list is the cause and effect diagram. It's also called Ishikawa or fishbone diagram. We will definitely discuss that, also called Ishikawa or fishbone diagram. We'll discuss those terms as we move along through the slides. The next quality tool is a check sheet, also known as a tally sheet. And then we have our control chart. Then we have a flow chart, histogram, our Pareto chart, which is based on an 80-20 rule, which we will discuss as we move along through the presentation, and the scatter diagram. So these are your 7 basic quality tools. When we look at the cause and effect diagram, again, also known as the fishbone diagram, some even call it a YY diagram. But if you hear the word Ishikawa, it is always associated with fishbone and cause and effect. This is a type of diagram that breaks down the cause of the problem statement, identified into discrete branches, helping to identify the main or root cause of the problem. Our flow charts show a series of steps that lead to a defect. Our histograms show a graphical representation of numerical data. Our scatter diagram is the graph that shows the relationship between 2 variables. Let's begin with our cause and effect diagram. Here you see the image of a fishbone diagram. Fishbone or Ishikawa, also cause and effect. So those are 3 names. If you're preparing for the PMP exam, you will need to know these 7 basic quality tools. If you're preparing for the Six Sigma exam, you will also need to know these 7 basic quality tools. So keep in mind all 3 names for this particular tool: cause and effect, fishbone, and you see why it's called fishbone, because it looks like the skeleton of a fish. And then Ishikawa. Ishikawa is the third name you want to keep in mind. And it's named for a quality guru, Kaoru Ishikawa, the trailblazer in the quality industry. He believed quality improvement is a continuous process and that it can always be taken one step further. This cause and effect diagram that you see here is a structured brainstorming tool. It summarizes your problem statement here at the head of the fish. And then the potential causes are arranged in these sets of bones or categories. And then you'll see these smaller arrows here in this particular diagram would represent smaller bones in the fish. These smaller bones are more specific type causes. Now, this diagram, this cause and effect diagram or fishbone diagram or Ishikawa diagram can be used proactively to identify possible risk with a process or implementations, but you're trying to identify a root cause or a possible risk proactively. Reactively, you could use it to identify potential causes or root causes. In creating your cause and effect diagram, you first want to name your problem or effect, again, at the head of the fish here where it says missed deadline. So this is the effect. Okay. Then you want to decide the major categories for your causes. And generally, you will use the 6 M's: manpower or people. And then you have machines, your methods, your measurements, your materials, and what we call Mother Nature or the environment. Some people even recognize these 6 categories as P, 4M, E. So the P would be for people, the 4 M's would be your method, your measurement, your machine, your materials, and then the E would be the environment. I like to recall it as 6 M's. Instead of people, you will use manpower, and instead of environment, it would be Mother Nature. So you decide on those, what your major categories for your causes, and then you start to brainstorm with your team and create your diagram. Now, you can use a wall. The first time I did this in a class, we used a wall and we used Post-it notes. And of course, you have your whiteboards that are in most environments now. But you want to go ahead and draw the diagram, create your diagram. And then there's another Six Sigma technique that you can use to brainstorm, and it's called 5 whys. You want to ask why 5 times in each of these 6 categories. And it may help you to generate more causes for this effect that we listed here at the head of the fish. You can also have silent or open brainstorming, where individuals on the team, they brainstorm, they come up with their ideas, and again, you can use Post-it notes. They just, go up to the whiteboard or the wall and they post their brainstorm idea there. Next, you want to review your fishbone or your cause and effect or Ishikawa diagram. Review the diagram, and then you want to eliminate any ideas or causes that do not fit. It's the process of elimination, because you will start to see a trend, some ideas that will fall directly into one of these categories. And then brainstorm for more causes. Okay. After you've done this, rinse and repeat, review, eliminate, and brainstorm for more. Then you want to identify the most critical causes. The most critical causes. And once you've identified those most critical causes, then you can verify the cause. You don't want to start tackling the effect just yet. You want to verify your cause, meaning you need to plan, you need to do some type of testing, okay? Verify your cause. Our next tool is a check sheet, or also known as a tally sheet. A lot of times in a practical environment, we see this check sheet in a spreadsheet form. Most of us are using Excel spreadsheets to generate our check sheets. So you can use spreadsheets. And it is a data collection form. As you can see it in this image, some data is being collected here. We're looking for the defect type, major or minor, the defects that are supplied, defects in supplied items, the days of the week, the total. So a lot of data is being collected here. Some common types of check sheets would be defect or cause check sheets. An example of this would be causes for a late shipment. And we see in this example here, we have the defects in the supplied items. We can also have data sheets as check sheets where we're recording readings or measurements, counts. For example, temperatures. In the food service environment, there is usually a check sheet for temperatures of the food, especially if it's going to be out on a buffet. It's just an example. A frequency plot can also be a form of a check sheet where it records a measure of an item along a scale. For example, the weights of packages may be recorded in a frequency plot, or even the gross income of loan applicants may be recorded in a frequency plot. There's also a check sheet called a concentration diagram, where it shows a picture of an object and it marks the defects. So you may see this damage done to a rental car. If you've ever rented a rental car, before you can get in and drive off, you have to do the walk around the car. And if there are any dents noted, it will be X'd on. Now it's a tablet. It used to be a sheet of paper with a few carbon copies, but now it's a tablet. So they will be annotated on that tablet. It's called a concentration diagram. So keep that in mind if you're ever renting a car and you're doing that walkthrough. That's really a tally sheet where they're collecting data. Our next quality tool is a control chart. A control chart. The control chart, it displays process behavior. It displays data in time order. Also, the average, or in Six Sigma terms, the mean, is used for the center line. So you'll see in this image, the center line is a process average. There are control limits that represent the range of expected variation, which is why we talked about reducing variation at the very beginning of the webinar. Reducing variation would be a Six Sigma task to reduce a variation. And usually this average, this process average here, your upper and lower control limits are usually 3 standard deviations off from the average. The control chart is definitely based on data, absolutely based on data. And it tells how a process is actually performing versus specification limits, which are based on customer requirements. The specification limits tell how a process is desired to perform, but the control chart tells how the process is actually performing. The control chart is used for establishing a measurement baseline. You have to have a baseline to say, what was it when we started, and then what would we like it to be? So the control chart establishes a measurement baseline. It's also used for detecting special cause variation. We'll talk about that a lot more as we move on to some of our other tools, because you do have common cause variation, and then you'll have special cause variation. Special cause variation is like one-offs or outliers. The control chart also ensures process stability. So reading the information, your data on the control chart, you will be able to ensure if the process is stable or not. This control chart also enables professionals to predict from the control chart. So it enables predictability. The control chart is also used for monitoring the process over time. You would select the control chart based on the type of data that you will be using. Because again, it's data driven. So you need to first define or identify if you will be using attribute data or continuous data. And then you need to interpret your control charts. Once you have plotted your information, you need to interpret the control charts. This is where you become empowered as a professional. This is where this becomes a tool for you in that interpretation. So you will test for special cause variation, and there are certain points on your control chart. Depending on where those points fall, above or below this process average, will allow you to interpret this control chart and allow you to make some very strategic decisions based on your interpretation. For instance, if you have six or more consecutive points, increasing and decreasing, that is going to show you a trend. If you see six or more points increasing or decreasing, you will start to see a trend on your control chart. If you have 9 or more of these data points consecutively, 9 or more consecutive points on the same side of this median, this average, that would show you a shift in your process average. And if you see a shift in your process average, then that's going to raise a red flag for you. If you see 14 or more consecutive points, all increasing and decreasing, this detects systematic effects. When you see these 14 or more consecutive points, all increasing or decreasing, this appears when there's a systematic difference in how a unit, and I'm using air quotes when I say a unit, travels through the process. So those, I could say, instead of units, it could be how a service travels through the process, or how materials travel through a process, or how a product travels through the process. So when you see the different points lined up above or beyond, or if they're trending, it will help you to make some very strategic decisions about the process that you have in place in your environment, a control chart. The next quality tool that you want to be familiar with as a professional is the flowchart. It's also known as a process map. The purpose of the flowchart is it visually documents a process. And as you know, we all have different learning styles. We have the audio visual learner. We have the kinesthetic learner. But for our audio visual learner, our visual learner, a flowchart or process map can be very helpful. It provides fact-based process description, and it helps the team to see how a process should work in its future state once the waste is eliminated. But when you're looking at this flow chart and you're constructing your flow chart, you'll be able to identify the waste and then eliminate it, which is the point of the flow chart. So there are different types of flow charts, and as we continue to present these webinars, I would like to show a little more of those different types of charts. But this particular webinar is about the 7 basic tools, but I do want to give you some additional information. So there's a flow chart or a process map called a SIPOC. SIPOC, S-I-P-O-C, is an acronym for suppliers, input, processes, output, and customers. The SIPOC is a high-level overview of a process. Again, you'll be looking at who are the suppliers, what are the inputs, what is the process itself, what are the outputs of this process, and who are the customers. So a SIPOC is a type of flow chart. There's also a spaghetti map, which is really a workflow diagram. It will help you to identify how information flows in the work environment, how materials flow in a work environment, and how people move in a work environment. A spaghetti map. Another type of flow chart is a swim lane or a deployment flow chart. And this particular flow chart says who does what. When you think of swim lane, you're thinking of swimming pool, the different lanes that are marked or demarked with the lines. And usually when you see a swim lane flow chart, it is showing a handoff between different departments or different people. So again, who does what? Which department or which entity does what? A swim lane is another type of flow chart. And then you also have a value stream map, which helps to eliminate the non-value added tasks within a process. What's more you want to remember about this flow chart are the symbols that you see here in this image, especially if you're studying for the PMP exam or your Lean Six Sigma exam. Standard symbols that are used in the flow chart, you'll see the flow chart will always have a start and an end point. So a start terminator and an end terminator is usually represented by a circle or even an oval. The rectangle will always represent action steps or tasks. The diamond is a decision point, also may be an alternate flow point, as you see here. And then the arrows, as you see in this particular image, the arrows are all flowing down. Well, in this flowing down here. Then you see some arrows flowing to the right. You may have some arrows flowing to the left in your process, but the arrows show the direction of flow through the process. And before you create a flow chart or process map, I would suggest that you collect your data about how this process is flowing by going to the actual workplace. In Six Sigma, we call it go to the Gemba, Gemba. Go to the Gemba. Go and actually watch the process yourself. You will be surprised what you will notice. In the world that we live in today, you're not using paper and pen so much as you're using your smartphone. Start a video, record the process, and then go back to your desk and document that process in a flow chart. That way you can get a more accurate documentation. Thank God for technology, right? Our next quality tool is the histogram. The histogram tells you about the underlying distribution of your data. That's the first thing it tells you. It also tells you what kind of statistical tests to perform. The histogram also points out potential improvement opportunities. Now, to create your histogram, you're going to need to determine your range of observed values. And you'll determine that range by taking a look. You want to subtract your maximum value, subtract your minimum from your maximum value. So maximum minus minimum will give you your range of observed values. Okay. And you want to divide that range into evenly spaced intervals. And as you can see from the image here, the bars do not overlap. So they're evenly spaced here. You then need to count your number of observations in each interval, meaning each one of these bars will have a count or a value assigned to it based on your observations. And then you want to create bars whose heights represent the count in each interval. So, of course, the smaller the bar, the smaller the value, or smaller the count. Now, in the top left corner here, you see the normal histogram, which is also called a normal distribution. You could actually draw what we call a bell curve over this normal distribution. In the normal distribution, or the normal histogram, the data is distributed symmetrically around this central value, so this central mean here. And then you also have your bimodal histogram, which has two peaks, i.e. the bi, so bimodal. Two peaks or two modes indicate two distinct pathways through the process, okay? Or one process is really two processes, is what you may find out when you start to chart your data in the histogram and you have a bimodal histogram. You'll realize that what you thought was one process is really two processes. And then you have at the bottom, you have your negative skewed histogram and your positive skewed histogram. So in your skewed histograms, your data values pile up towards one end and tail off towards the other end. Okay, and this occurs when your measurement devices or your methods are inadequate, or maybe they've been tampered with. And then your information will be displayed in a skewed histogram or a skewed mode. But again, the normal histogram is indicative of your data being normally distributed. So what I think is empowering about the histogram is your count, and that each bar is representing that count. So you can very easily make a decision based on where your data is falling, where that data is based on your average or your mean. Your next quality tool is the Pareto Chart. Your Pareto Chart, also known as the 80-20 rule. The 80-20 rule. This Pareto chart, again, it's another bar graph, as you can see here, but it's a special bar chart. It focuses on the components of the problem that have the biggest impact. So earlier I was saying with the histogram that what's so empowering is that you can look at that histogram and see the tallest bar, has the largest count. Well, here in your Pareto chart, it is used with continuous data. You must use continuous data when you're charting your data in a Pareto chart. And it's based on this Pareto principle. You all may have heard of this principle before. It sounds like this. It says 80% of the effects are due to 20% of the causes. Okay? So 80% of your problems are due to 20% of the people. 80-20 rule. So the bars of the Pareto chart are arranged from largest to smallest, as you can see here. That is one way that you can identify your Pareto chart as opposed to a histogram. Again, your bars are arranged from largest to smallest. And that is going to help you to focus on the components of the problem that have the biggest impact, because the biggest impact will be on your x-axis. Again, the Pareto chart also helps to determine which categories will yield the biggest gains if addressed. So you know when you're looking at the histogram that the bars are arranged from largest to smallest, the largest bar is going to yield the biggest gain if it is addressed. And also, the Pareto chart also allows us to determine which bars are our minor contributors to the problem. So we won't waste time on the smallest contributions to our problem. We want to tackle the ones that will give us the biggest gain or the quick wins. In the Pareto chart, we want to compare the frequency and or the impact of different causes of our problems. We also need to set our priorities, and then we need to define our problems and or opportunities. Once we define our problems or opportunities, we get to determine our root cause. Usually, if you're using your Pareto chart, most times the software will allow you to drill down into these bars. So if you can use some Six Sigma software, or if you're using an Excel spreadsheet, you may be able to drill down into these bars, and that way you can determine your root causes. The Pareto chart also allows us to gather and compile our data. You need to collect at least 50 points of data across all categories for more reliable interpretation of this Pareto chart. You need to total each category and also determine your percentages. In constructing your Pareto chart, you will draw your X and Y axis, X-axis, Y-axis. Your X-axis should be at least tall as the total number of incidents or impact observed. So here, your x-axis needs to have the tallest bar. And you want to draw your bars in descending order from left to right. In descending order from left to right. These are all things that will help you visually identify the Pareto chart. And then also, once you're familiar with the Pareto chart, it will also help you visually identify root causes very quickly, which is very empowering for a lot of professionals in their work environments. You also want, in constructing your Pareto chart, you also want to add your percentage notation on your vertical axis, and that should be from 0 to 100. And then you want to draw your cumulative line. This cumulative line, you will come to your totals for this cumulative line by adding the value of each bar from left to right, and they should total 100%. If someone wants to take the time right now to add the total of each bar, 57, 48, 39, 16, let's see, it'll bring us on to 100. That's 95 right there. Okay, our next chart, next tool is our scatter diagram. The scatter diagram. Also, this is a graph. This is a graph. You will be plotting your data on a graph. And this graph is showing a relationship between two factors or two variables. It displays patterns in the data, and it's either going to support or refute the theories that you have about your data. The scatter diagram also creates or refines your hypothesis about your data. It also predicts effects under other circumstances. This scatter diagram also allows the width or tightness of the scatter of your dots or your data reflects the strength of the relationship. So for instance, we see in the bottom left corner here, there's no correlation because the data points are all scattered. There's no line formed, no pattern formed there at all. No pattern, data points are scattered randomly. But here, where there's a positive linear correlation, you have large values of one variable that are associated with large values of other variables. For instance, taller people tend to be heavier. So if you plotted the height and weight of tall people, then you would see that there's definitely a positive correlation between those two factors or those two variables. In your negative linear correlation, large values of one variable are associated with the smaller values of other variables. And this negative linear correlation, it will begin in the top left corner and descend to the bottom right, as opposed to your positive linear correlation, it starts in the bottom left and ascends to the top right corner of your graph. And then we have what we call a non-linear, some call it the curvier correlation, or a complex pattern. This often occurs when there is some factor at work that interacts with one of the factors. So you would use what we, in Six Sigma, we use a design of experiments or multiple regression to discover the source of those other factors that may be interacting there and causing this non-linear correlation. You would have to test. An example of that negative linear correlation I wanted to give you is to give you an example of your positive correlation. Taller people tend to be heavier. With a negative linear correlation, students with many absences experience a decrease in their grades. Or when the weather gets colder, the cost of AC decreases. That would be a negative correlation there. So you see a decrease, i.e. the word negative. And these are your 7 basic quality tools. Again, you have your check sheets, your fishbone, also known as an Ishikawa diagram or cause and effect diagram. You have your Pareto chart, which is also known as the 80-20. It's based on the 80-20 rule. 80% of your problems are caused by 20% of the people. And then you have our histogram, flowchart, scatter diagram, and our run chart. 7 basic quality tools. I'd like to use this last few moments for any questions. If you have any questions, please list them in the chat. We would like to address those questions. I do thank you for taking the time to educate yourself or become more acquainted with the 7 basic quality tools. It is my pleasure and my honor to host this webinar on behalf of GreyCampus. Again, my name is Phyllisia Taylor, Project Management Professional and Lean Six Sigma Green Belt Professional.